Hey everybody, we're going to do yet another Critter Stack live stream. Get things started, and I'll jump right on. With a modular monolith style of architecture, a little bit in general, but a whole lot about some of the specifics of how the Critter Stack can help, how the Critter Stack, and especially Wolverine, has had to change a great deal to make it possible. And honestly, a lot of reservations that I have about this architectural style. I'm not quite, just not quite there with the community hype, and I'll try to explain why. All right, so I don't want to belabor this point because we all know this. You know, what came before? How did we get here? You know, in the old days, 10 years ago, monolithic applications, code bases that just got very large, maybe they got complicated, just got a lot of stuff glommed on them. It was very hard to keep those applications large code bases, keep them in a state where they were still easy to work with. Most of the time they weren't. Basically, the big monoliths, the way we were doing it back then, kind of sucked. So we tried microservices, the idea that you could split things up into smaller services. People did stupid, kind of crazy things, pushing the boundaries. It was kind of the classic Martin Fowler quote: the only way we know a programming technique, how far it goes, is to go a little bit too far and then come back. So I think pioneers have definitely found the limits of that. There's some things that can be better about microservices if you happen to get the boundaries just right, which most people don't because, it's hard. You get to a point where you have smaller code bases. Maybe teams can actually handle an entire code base by themselves. That's awesome. But then you have a bunch of stuff deploying at the same time. There's more DevOps work. And as everybody knows, it can be a bear to debug problems between services because now everything's remote. So I think that's nothing I said is terribly controversial. There's one problem here we're going to get into, and that guy's actually a Martin, but I love that picture so much when PowerPoint recommended it that's where we're going. One of the problems that we faced as a community with Wolverine was very much conceived of in the early 2010s, mid 2010s, in the very beginning of the hype cycle of microservices. And it was very much originally optimized for microservices. I'd argue that a lot of kind of core .NET, a lot of the .NET core abstractions, the very basic foundation stuff, the iHost, the way we register services, a lot of the technologies we use are optimized for a world in which there's only one. Somebody please do the Highlander quote, but there's only one of those things in an entire application. Wolverine users that have pushed on modular monoliths, you'll know we've had some existing friction and still a little bit continuing with the separated behavior. I'm going to talk about that as well. So moving on. And hey, I'm going to try to watch the chat. So if anybody has any questions or thoughts or wants to talk about something totally different, just chime in anytime and I'll try to catch it. So, the pendulum, everybody who does a talk on modular monoliths always talks about the pendulum sliding back and forth. And now we're going back to monoliths. So, let's take this whole value proposition, the theoretical proposition. What if we could still have some of the advantages of microservices, in terms of having parts of the code base that are still easier to reason about or to work with a little bit in isolation, but we don't have to worry so much about all the distributed programming stuff that was really hard about microservices. And maybe it'll be easier to adapt and figure out what the bounded context really should be, which is a real value. So, when people talk about this of getting the best of both worlds, it just makes me think of people having mullets, the mullet haircut, and, kind of growing up in the 90s when the mullets were really, really bad. This theory of getting everything in one package, it's Billy Ray Cyrus's achy breaky heart for me. it was a big hit. A lot of people were into it. It's not the music you're going to go back and rewind from the 90s right now, right? All right. So, if you've seen me online, you follow me online, I think the whole modular monolith idea is overhyped. I think there are very real technical challenges ahead of it that I don't think people are as cognizant about as they should be. I think that a lot of the celebrity programmers, especially the people that make more than you and I putting out YouTube content, I think they oversell the advantages and they drastically under communicate about the potential problems. Right. So, a couple things I wanted to at least talk about. The concerns I have. The first thing, this comes straight out of extreme programming. It's the idea of reversibility. How easy is it to change your mind once something is baked into your code? Is it baked like concrete, or is it baked like, I don't know, like markers on a whiteboard where you can just erase it and rewrite it in a heartbeat? So the challenges with microservices and with modular monoliths, your ability to redraw where your your bounded contexts are, where the modules actually are, it's much easier if it's one code base. It's easier where you can compile and test it all together. Maybe this gives you a better chance to be able to adapt and get your service boundaries right as you kind of learn what are they. The biggest point I'm going to talk about here is, how do you really achieve modularity? And is this really just kind of bogus? Is this really just old-fashioned monoliths? Which I think for some people it really just is. So we're going to talk a lot about the difference between maybe trying to do this with synchronous inline code and a lot of abstractions, or do you go the full Monty, and do you go to asynchronous messaging between your modules, more of a message-based architecture, even if it's running in one module, which conveniently enough, Wolverine's really good at. An idea of severability. I don't think this is a term I made up. I'm pretty sure other people use it. Monoliths, there are still problems with monoliths. Ideally, we'd like to get to a world where maybe if we can find, this part of the service doesn't interact with the rest of this part of the monolith, and it really is a well-defined boundary, it would be nice if we could kick that outside to its own service later on. You see this referred to as like the outpost pattern of, we're going to get an ability, kind of a way to take this out of the huge conglomerated castle and move it out to be its own thing, where that can be easier to maintain, because smaller systems are easier to maintain. So the idea of severability, it's, can we keep looser enough coupling between our modules that there is a roadmap and a technical way that we could pop out one module and move it to its own thing later, or maybe a different thing. So that's what I mean by severability. I think just kind of a general theme for me the last 5 to 10 years of software development, it's understanding exactly how important it is for folks to be able to reason about the code they're working on. And a lot of these systems that we say are hard to work with, I mean, some of it's slow build times, slow tests, high ceremony systems where you just have to type a lot of stuff to make something new. The single biggest killer I think I've seen in the last 10 years is just how hard is it to reason about the code base? Can you understand where you need to go into to make a change? Can you understand when you make a change, what possible side effects that might have downstream? Where, if it's hard to figure out what's going to happen when you make a change, it's regression bugs, slower development cycles, so on and so forth. Part of the theoretical promise of a modular monolith is trying to have modules a little bit isolated from each other so that you could you could do a lot of productive work just inside one module at a time, and only really be worried about, at least some of the time, about that one module. So you don't have to have the whole system in your head. We're going to get into quite a bit about the databases. There's been a lot of work, really just in the last week, making Wolverine a little bit better able to handle all the silly, complicated. Let me back up. All the very real scenarios that people are coming up with where they want to use a Wolverine application with Modular Monolith and potentially have databases that are multiple databases and even use databases with different technologies, right? And then back to that idea of severability as well. Let's say you're going down the path of Modular Monolith, but you want to leave yourself open for the ability to yank things out later as you figure out where the good boundaries really are. Just having a thought for how could we work with the database and still kind of leave the door open to breaking things apart later. Talk about both EF Core and Martin. Of course, I think Martin does it far better than EF Core because, of course, I think that. We'll talk about both. Just kind of moving on. Transactional integrity is also going to get into one of the things that I think people skip over with the hype around modular monoliths. I personally think that if you really are trying to be modular, I think you're more likely than not going to go down a path of wanting to do some asynchronous messaging. Use some kind of messaging-based workflow between your modules. And if you do, and you don't want work to be lost, you're going to have to be using a transactional inbox and outbox. And then we get into this issue of, well, what if you're using a whole bunch of different EF Core DB contexts or a bunch of Martin ancillary stores, or you're even mixing Raven DB in the mix. But you want durable messaging for each one, but maybe also you want to try to be as efficient as possible and let modules share the inbox outbox kind of overhead. You're going to get into that. That's a big deal. I don't see anybody else but the Wolverine community talking about it, but it's got to be something everybody faces. All right. And folks, I know it's a small group, but chime in anytime anybody wants. All right. So I'm sure there's a lot of other types I'm missing, but talking with people online, I think I see people kind of visualizing how a modular monolith is going to work, kind of in one of two ways. Some people are really just going down this path on the left of it's really just the same old monolith we did before, but maybe we're going to, try to care a little bit more about solid. We're going to use a little more dependency inversion, which really comes down to we're going to throw a lot more abstractions in between things. Maybe we're going to throw the old Gang of Four facade pattern between module A and anything in module B. So module A doesn't reach into the DB context for module B. It always goes through some kind of controlled facade so that module B has some control over how it's being worked. I think that's probably okay for smaller and medium-sized systems. I think that's going to leave you to synchronous workflows between modules. I had a discussion last week. Some people think that if it's a synchronous workflow and everything's in process, debuggability is automatically good, right? And I think the answer is not necessarily. What I'm worried about with synchronous workflows is I think that could potentially get you in a place where you're doing very deep call stacks of, you enter an HTTP controller that calls a service in module A, which might have to call a couple other helpers, which is potentially making database changes, but oops, you need to affect some kind of a change in module B. You're calling through module B into its facade, which is now calling in services, repositories, down and down and down. And everywhere in this call stack, you could be making different side effects. You could be calling DB context. You could be calling save changes multiple times, which happens all the time. And persistence-oriented repositories where the repositories do their own save changes. Or maybe you have to use a separate unit of work, and now you need to be smart enough to know what's the scoping on my unit of work, sharing it with the DB context or Martin or whatever it's going to be. But the point is, if you get into a place where you have a deep call stack of where work may be happening at every point in a long, deep call stack, maybe they're making different database changes, maybe they're querying the database and making the exact same queries, maybe they're committing transactions. Where's your transaction integrity? Are you really getting one logical transaction the whole way through, or not? Because that can easily get your system in a bad state if something fails in the middle. And some of you are going to rightly say, well, what if I just use a transaction scope, an ambient transaction scope around the whole thing? Maybe. I try to avoid using those things as much as possible, partially because I'm old enough to remember the MTS server and Com Plus, and I'm naturally quite afraid of distributed transactions, even though transaction scope's technically not distributed. But even so, you're still stuck in a world where all these different layers could be making lots of different database calls and even duplicating queries. I bring this up because I've seen it happen a lot of times. And when that happens, that's database chattiness. Sometimes that's the very most common cause of poor performing enterprise systems, at least in my work the last 10 years. Probably was before it. And then we still need to worry about the strong consistency. All right, the last bullet point. Could technically use a mediator to sit in between separate modules. Technically, Wolverine's a mediator, but even saying that, I'm not a huge believer in the mediator pattern. In most cases, there are exceptions. I think it's still in line. I think you still have all the problems with transactional management. I mean, you could kind of work around it by transaction scope, but I think you have very limited error handling capabilities with these mediator tools because they're in line. I don't think a lot of people understand that anytime you call through to a mediator is probably a nested transaction. Anyway, and it's just more hops. So especially when you're talking about just using a mediator just to get a query from another module, it's not the worst way in the world to build a system. I'm just personally not a fan. Okay. Moving over to the right, this is kind of my territory. The other way people try to go at modular monoliths is they get real serious about maybe a little too much upfront, but they try to build in using messaging upfront as a way to decouple your modules by saying kind of upfront, hey, the way that you're going to communicate between one business process or capability and another is asynchronous messages, even if it's technically running in the same process. All right. And this is a great place. This is where Wolverine comes in. Wolverine has strong support for both an in-memory processing with a message bus or with really no change to your own handler code or anywhere where you're publishing messages. You can change in the same app. You can mix and match it with messaging with external brokers. So this is where a lot of the Wolverine challenges come in and a lot of the Wolverine specific things I'm about to start talking about. Jeffrey, I'm glad you're on. So we got one person old enough to recognize my references. So one thing to worry about, just be heads up, anybody that's trying to do modular or monoliths. If you're going down an event-driven path of, let's say you have your item module and you create a new item and you publish out some kind of item created event that might be handled by more than one other modules, or you're just publishing a message that needs to take some kind of corresponding action in another module. You're getting into the world of eventual consistency. Something that Wolverine handles pretty as well as you can, but just eventual consistency, even though it can be very valuable, that's going to be a little more troubleshooting. That may be conceptually hard for a lot of people who aren't used to dealing with that. And even if you are used to dealing with it, it's still not perfectly possible. I'm just saying it can be a challenge to debug or understand. And you always have the issue of, well, what happens if, somebody from a UI does something and it looks like the state looks like their work, their changes, their actions didn't get captured. So, yeah, which, on that hand, Jeffrey and I are going to be working a lot with Signal R with Wolverine in the next week or two, in no small part to be able to handle asynchronous workflows. Not that that's the easiest thing in the world. Guys, I promise there is code coming up pretty soon. I don't really have a lot to say about how to find your module boundaries. I was so heavily influenced by extreme programming and early agile programming before Scrum killed it, that I tend to rely on adaptation. I mean, you can plan things out, but you're always wrong. What I think you want to look at for the how do I figure out where my module boundaries are? I pay really close attention to, any pieces of data that you have to have a strong view of. I need to know what the account or maybe it's I need to know what somebody's account is and what the on-hand inventory is to be able to make a decision. And I have to know the exact right data of both. It might be telling you that those two things are really one module. If you have to be strongly consistent across them I allow an order to happen, but I also need to have enough inventory to fulfill that, maybe the order and inventory is one module. I mean, there's a temptation for all of us. The easiest way to divide a system up is to assume it's going to fall on the boundaries between, logical big entities in the system. But that's not always helpful, and sometimes it's even very actively harmful. You want to look, I guess, too, as well, when you have to make changes, and I think anybody who's done microservices, you probably suffer through this. If anytime you're changing one microservice, you almost always have to go change a second or third microservice in some kind of corresponding way, that's probably one module. Maybe combine them together again. And the same token, if you find within a module, the different parts of a module are changing at totally different times independently, maybe you can split things up. So this is really simplistic, but just kind of thinking, what data elements have to change together, or what things could be changing eventually afterward. And then always paying attention, what code, what functionality tends to have to change together or independently. And you keep the things that tend to change together, keep them closer together, and separate the things that aren't. It's overly simplistic. It's really broad in general, but also kind of works. All right. So, when I was originally planning this out, I was going to think mostly about newer challenges and newer functionality in Wolverine. But this is a good time to just, anybody who happens to be a little bit newer with Wolverine, let's look at some of the local messaging built in with Wolverine. That tends to be a really good helper. Let me slip in here. I think, Jeffrey, if you're up for it, I think maybe in a couple of weeks, we do a real formally edited one of these on vertical slice architecture. For just now, let me get away with saying Wolverine's pretty good at it. Now let's talk about some of the things we can do with Wolverine messaging. So get into just the bootstrapping of an application. It's the incident service example. There's not really much to it. But let's just say there are message handlers in here already. I want you to focus on just a little bit of very simplistic Wolverine bootstrapping right here. Just want you to know, without doing anything else, every message handler that's in your system, and Wolverine has, out of the box handler discovery that works for most people. out of the box, without doing anything else, every message type that has a local handler, Wolverine is going to route these to an individual queue, local queue for every message type. When I say local queue, this means it really is queued in memory in your own process here. So even without it adding an external broker, this is going to give us some external asynchronous workflow within process. This gives us an easy way to do asynchronous programming between handlers. So one module can have their own handlers, and it can drop off messages to another. So I said the magic words in memory and process. If you're coming to this new, you're of course thinking, well, what happens if Kubernetes decides to recycle a node, which I've talked to people about today. What happens is that work all get lost. So potentially, but let's talk about this a little bit more. So the same application already has Martin added into it. So you can see a little bit, there's add Martin. Most importantly, I've said, hey, I want to integrate this with Wolverine. One of the things that this is doing is this is setting up a Postgres-backed transactional inbox and outbox for us that we can then attach even to our local queues. Well, we can go kind of a big bang thing. You can do this a little more granular, but let's say that just there. All right. So one line of code. Every local queue now is durable, means that it is backed by the database. So every time you publish a message to one of these local queues, it's actually saved in the database. And as soon as it's handled, it'll be marked as handled. Trying to do this within transactions. So if you're writing handlers that use EF Core, DB context, or a Martin document session, or a RavenDB document session, it is trying to save the message body at the same time as the real transaction. It's even trying to use the same database round trip. Ton of little performance optimizations. Again, kind of continuing that argument of why you don't roll your own for these kinds of tools, because there's a whole lot of thought and micro optimizations that are buried in the internals here that you just simply aren't going to recreate quickly on your own. So the point of doing this, it's going to slow you down a little bit because you're making more database writes. What this is going to allow is, if you got a node that's running work and fails suddenly, or Kubernetes decides to sig turn it and kill it without letting it shut down gracefully. Once another node starts up, or if you have other running nodes, they will be able to pull this out of the database, pull it into their own local queues with the same local queue set up, and run there, and just off and they go. Of course, we can do more granular routing. So we could say, I mean, you wouldn't bother this with one message, but maybe what your issue is if you want to say that all messages of a certain marker type and I'm totally making this up here. So your own marker type, that's not terribly valuable itself, but maybe what you really need is you need these types of messages to go in a very strict order. I can do that. Or alternatively, I could say that, hey, we'll actually let Wolverine do as many as 10 in a row, 10 at a time. Behind the scenes, once we get to Wolverine 5.0, the behind the scenes is the system.threading.channels library. Older versions of Wolverine, it's TPL data flow, but it'll soon be channels. So you have a lot of control over what your parallelism is versus strictly ordered or not so ordered. By running through local queues, you get the whole host of Wolverine error handling. So we can set up retries, requeue it. We can schedule a retry, take it completely out of the in-memory queue and say, I want you to run this in an hour from now. Working with I was helping a client in the last couple of weeks that has to deal with external systems where they have kind of maybe oddball rate limiting issues where sometimes you can detect that, hey, this downstream system is just down. I can't talk to it at all. You can use the Wolverine error handling, even with just local queuing. We'll set up circuit breakers. And more. So that, if there's a certain amount of errors, just kill this. If it's long, I don't even remember how to use that. We could set up error handling to pause any local handling. If you receive an exception that just says, hey, maybe this downstream system is just down. So don't do anything for an hour. Just stop immediately. Other cases, maybe you have pessimistic error handling or pessimistic locking. Like I've hit this with old banking applications. Or we can say, hey, if we happen to see, the certain pessimistic lock exception, what it kind of tells us is somebody's got it reserved. There's no point in retrying it right now, but maybe if you try it for an hour, we can say, schedule a retry. I want you to do this in an hour. This will take it out of the local queue. It's going to keep it in the database. An hour from now, probably a little more than an hour from now, it'll try to rerun this again. While I'm cleaning up, anybody have any quick questions or thoughts? Well, get back to PowerPoint. Yeah. Okay. This is a big thing I wanted to bring up at the end. So if you're using the messaging with Wolverine, even if it's local, that's giving you the full open telemetry tracking. You can. So Mike, the default parallelism, it is the environment processor count, which, I don't know why that makes sense to do it when there's however many local queues, but it's what everyone else does. And it's kind of arbitrary, Mike, to be honest. But it's the environment processor count. The open telemetry tracing, especially if you're doing any kind of asynchronous stuff, you need to understand cause and effect of handling this message led to a second message type that maybe hit a third handler. The open telemetry tracing will give you that full traceability, assuming that you're exporting your OTel in something, and also that you're much better than I am at being able to use those Prometheus Grafana type tools or Aspire. That's going to give you it's going to give you correlation and causation between things. I think that's really helpful. I mean, just thinking too about, I told you that I'm personally kind of afraid of the deeply nested calls that you might get from trying to just synchronously call each other. Doing the messaging kind of builds in a lot of the tracing of what caused what, where you're just not going to have that as cleanly if this service is calling that service is calling that. And even if you try to do that manually by just sticking in a ton of log messages, then that's a lot of noise code that makes the code harder to read, and the log messages aren't really helpful. That's just my thinking on that. All right. So the biggest single recent cause of heartburn for me, this is some new stuff here. So it's modularity with Wolverine and databases. First, I want to talk just a little bit about that severability idea of, we have modules. Maybe you're targeting the same database today. If core actually makes it pretty easy. You can have as many DB context types as you want, all targeting the same database. Maybe use different schemas. If you isolate it between schemas, maybe it's pretty easy to move it to a separate database later. Scaling needs, whatever it's going to be. To some degree, you're kind of just, it's a little bit of a social contract of, hey, folks, let's make sure that let's try not to do a lot of foreign keys between schemas because that's going to hurt our severability. Maybe you just live with it temporarily. I think that's fine. With Martin, I don't think you need to worry about using separate document stores. If all you're doing is documents, you have the ability to override schema names on a document type by document type basis, which I thought was insane when we first built that like 8 or 9 years ago from community stuff. But it's there. It's helpful with modularity, modular monoliths down. The exception is the ancillary store with Martin, where you can say I have iModule store. That might be valuable for, especially if you're leaning really heavily on event sourcing, or even if you want to scale event sourcing. If there is a way, it's a drawback of Martin's model that all the events for a single store go into one single table, which can be big. If you have some events for different modules that are really pretty isolated, the ancillary store model I'm about to show, maybe it's advantageous for scalability, even if you don't care about severability or modularity later. Let me show you some of the newer stuff and also some of the things that have been kind of challenging. So this first thing, this is actually looking at Martin. So this is using a couple different ancillary stores with Martin. Maybe we're going to keep a things through an iThing store. If you've never used this in Martin, we can kind of have Martin, one application targeting multiple Martin document stores, even if it's really hitting the same database, maybe different schemas. That's something that's helpful. This is just a trick in Martin. So I have an interface. I have a document store. And I'm not showing here. Martin also has some helpers so that you can tell it when a certain handler is. This should be using iThing store. And that'll help keep all the inbox, outbox stuff just working just the way it should be. But in this case, we're going to have players and we're going to have things. And they're both separated. Let's see. In this case, yeah, they're actually using separate databases. Completely separate physical databases. This is a relatively new thing in Wolverine. This will be part of Wolverine 5. In your application, it is going to be able to set this up, and in the main one too. So we have two stores that are both hitting the same Postgres database, and then a third module that's hitting a completely different database. Just let that sink in just for a second. Because this is super challenging for me. So what we need is the two modules that hit the same database. And we're also going to tell it, hey, I want the message store schema name to be just Wolverine on everything in the same database, unless you override it. Well, that's going to help Wolverine out by being able to use one transactional inbox and outbox and backup process for one Postgres database. Just so you know, the inbox outbox is kind of expensive. So it's a big advantage if you're getting aggressive with this modularity stuff. If you could still be using the same logical inbox outbox in the same physical database, that'll help Wolverine run more efficiently, hence your system. But also, this guy here that's on something totally different. Wolverine 5 is going to let you address totally separate databases within the same application, the same mechanisms in your transactional middleware. You're going to be able to do the inbox, the outbox, scheduled messages somewhat transparently within your system, and it's just going to work. Please clap. That was so much work. Even to the point where, let me find a good example, folks. Yeah, one system. This one system is from testing. We've got EF Core using SQL Server. We also have Martin. Martin's going to be your main Postgres is going to be your main message storage. That's important. And then we're going to have another Martin store. So 3 modules total, maybe, hitting 2 different Postgres databases, one SQL Server database. We got a mix of EF Core. We got a mix of Martin, and it's all just going to work now. I do have to do just a tiny bit of help now. Not saying that this won't change, and this isn't documented because I finished this just yesterday. So, a little bit of double entry, but I'm setting up message storage with SQL Server. So SQL Server based, backed, transactional inbox outbox. I'm going to say that anytime you're using items DB context in a message handler or an HTTP endpoint, this is going to help Wolverine know, I'm going to use, this is the database I'm going to use for inbox outbox with this thing. And that'll help Wolverine set up a little more middleware behind the scenes and just make it work so that you get that transactional inbox outbox stuff for durability that you really, really, really want. All right, as I breathe. So Mike, the DB apply tool is database aware. It is aware that there's more than one database out there. And I think I got to caution folks that all those Weasel command line tools, even if it's one physical database, the critter stack is still identifying it with the URI that's going to tell you, is it Postgres or Martin or Postgres or SQL Server or Raven? What's kind of its role within the system? You'll see some that'll say Wolverine DB as the scheme, and it'll tell you server, database name, schema name. Some of the command line operations, and I don't remember exactly which, Mike, some of them will just automatically do it against all databases. I think DB apply would hit every database that it knows about. So the Martin stuff, the Wolverine Postgres stuff, the Wolverine SQL Server, it would be able to loop through and do it all at one time. It's not smart enough to fail on one and keep going. It would fail on the first one, but to some degree, I don't know how this is going to work out in real life, but it's there. And my kids are in the next room fighting over Fortnite. Remember what else I wanted to talk about? So I'm kind of excited about this just from the standpoint of it's a capability that some people have asked for. Really did this work now because we're in a big initiative to finish Wolverine 5, and it's built to support the Critter Watch tool that is actually in production, or not in production, but heavy development right now. So we're using the database back dead letter queuing. So we had to get this sorted out. Part of what Critter Watch is going to need to do is know how many different databases I need to reach out to for each application. How do I talk to them? How do I find them? How can I query one or the other? So that's why we had to deal with this now. All right. So Jeffrey, more Gen X stuff that people won't remember. I post this about every 2 or 3 weeks, usually because strong type identifier, sometimes because of this. Wolverine was originally built for a microservices world, and sometime in 2012 or 13, a couple former colleagues and I were at a whiteboard designing what was going to be our new messaging framework, and we decided that the way middleware was going to work is you would just have a separate handler that took in an abstract class or something, and we would potentially run multiple handlers per message type. And that has been an endless source of friction and aggravation in Wolverine in the last 2 years. So let's talk about this a little bit more. By default, to try to make Wolverine just be easy to use, there is no formal mapping of this message handler has to be associated with this queue I'm listening to. It's just smart enough to know, oh, I got this message type and I know there's a handler. So I'm just going to call this handler. Which works great until you get into this modular monolith thing where you might want to have completely separate handlers for the same message type that are distinctly separate actions and be tracked separately, succeed or fail separately, just everything separate. So the Wolverine approach to this first, it's sticky handlers. Is the first bit of help. Boom, boom. So for a single message, so sticky message, you gotta love the name, right? If I have two completely separate, logically different handlers for the same message type, sticky message, I have to start telling Wolverine, hey, this one needs to go to one queue or the other. This one by default, it's going to use local queues, but what's going to happen, this is going to set up publishing rules so that any message that's received at the blue local queue will run this. Any message of the same type at the green local queue would get this one, or RabbitMQ, or AWS, or whatever it is. That's the simplest thing we can do. This, of course, has gotten a lot more complicated. This is enough to get you through a little bit. We also ran into this problem of, well, I don't want to manually set up the sticky relationships for everything. That's going to be too much friction, which it is. So we came up with, what do you do with multiple handlers? So one of the problems for me as a maintainer of Wolverine is, on Martin, is you try really hard not to make any breaking changes to behavior that would impact people in ways that aren't obvious from the API. So that's why you get all these opt-in, opt-out kind of rules. And a new one is, if you're doing a modular monolith and you're going to have multiple handlers for the same message, you probably want to go to this multiple handler behavior separated mode. Even that by itself is enough that that'll put different handlers for the same message type. It'll route it to different local queues if you're only using local queues, and it'll track these things a little bit differently. It's getting a little more complicated than that. This will set up kind of kind of a fan out locally. So if you publish one message that goes to multiple places, Wolverine actually kind of almost keeps two separately tracked copies of the same message, handling in different places. So you got separate retry loops, separate everything. The correlation will still go back to the original sender, but in all important respects, they're completely isolated and separate, which is probably what you want. Just in the last 1 or 2 Wolverine 4 releases, and this will be the last big thing added to Wolverine 4, most likely. For both RabbitMQ and Azure Service Bus so far, the conventional routing is aware of the separated behavior. And like it's the case of RabbitMQ, it will create a queue for each individual handler type. So your problem is, what if you are potentially receiving the same message from outside? Like maybe it's a Rabbit exchange that's fanning out to two separate queues, and you want to listen to both queues. So you're going to get to do something like this. Now, for both Azure Service Bus with topics and subscriptions, or RabbitMQ with RabbitMQ exchanges and queues and bindings, the conventional routing is smart enough to set that up for you. There's one more little setting, something, again, something that was never important until now. If you happen to be using, if you are listening to multiple external endpoints for the same message type, like something is using a fan out externally, you may need to tell Wolverine, hang on one second. You may need to tell Wolverine, hey, the identity of a message, instead of using just the ID for the durable inbox outbox, now you've got to say uniqueness is the identity and the destination, what queue it came in at. That's for folks that were publishing the same message from outside to the same application in more than one place. It comes from like a RabbitMQ exchange that's fanning out to two or more queues, but all being listened to by the exact same application with the same message store. Yeah. So that's there. That's something that's available. And for anybody who loved the movie, The Sandlot, you're killing me, Smalls. All of you who are asking for this kind of stuff. Mike's asking, are there any performance downsides to using sticky handlers? No, not really. No. I'm going to say no. A tiny bit of overhead of technically probably just barely, but I think it's usually so important that the individual handlers succeed or fail or retry at separate times, or one can succeed and the other fail, that I think that absolutely trumps the teeny tiny bit of efficiency you might get from running multiple handlers in one logical transaction. Hope that helps. On that, we're close to time, and floor is open. Anything anybody wants to talk about. If nobody has anything, I'm going to show one barely new thing for Wolverine 5.0 before we get out. But floor is open for anything anybody wants to talk about or ask about. Oh, and RB, thinks that's nice of you to say that. Well, I'm glad I included that section. I have a tendency to kind of forget about stuff that's older because, it's there. People don't complain about it and forget to talk about it. All right. I got one more thing I want to talk about. But I talked about this on yeah. All right. This has been something I've been wanting in Wolverine for quite a while. So if you're using the full critter stack, something that comes up pretty often from JasperFX clients, or I see from them, is needing to do, real life stuff. You need to do operations that need to span more than one event stream. And you need to do it transactionally, which Martin can do just fine, no problem. So this is an example I used in the documentation in a blog post. Transferring money from one account to another. So we need to know the information. We need to know both accounts. What do you have on balance? And then when we do it, we're going to pin a debit to one, credit to the other, or withdrawal, whatever it is. We need to do this all transactionally. Awesome. My local branch, not committed because there's problems. When you do this now, so this is one call to fetch for writing. It's the second call for fetch for writing. Wolverine is now able to generate code behind the scenes that uses Martin's batch querying, so they can go grab these all at the same time. And even farther, if you went even farther and started asking for, I don't know what this would be. For anybody that's used the kind of declarative data access part support in Wolverine, where this is going to try to load a Martin customer document by an ID, this would be part of the batch query as well. So, think of all those places in your code where you reach out and make successive requests to the database to get a little more information to use in your handler. Wolverine's going to be able to batch a lot more of that up, which you always could have written explicit code to Martin's batch querying, but that code can be kind of busy. And a lot of people don't know it's there, may not even think to do it. With Wolverine 5, Wolverine's going to look out for you and try to give you the most efficient interaction with the database possible. I'm really excited about this. And for anybody who follows event sourcing, this is probably going to make up the bulk of our reaction to the dynamic consistency boundary stuff that the commercial event stores are trying to do. We think this is going to give us a model to just be easier. So, Mike, how does this work with revisions? You're going to have to let me get back to you on that one. That one's still a work in progress. I think what's unfortunately going to have to happen is you are probably going to have to specify do a little bit of extra mapping of, your command may need to send up the version of both, one or the other. I don't have a great answer for that yet. I've thought about that a little bit. I don't have a super great answer for that yet. Kind of the question is, how do you opt into just the right optimistic concurrency here? Especially when you got two streams. So there's going to be some way of explicitly mapping, here's the version from one coming in, and here's the version for the other. It would also be able to do exclusive locking, though. You would be able to do that today, with all the obvious downsides of exclusive locking. All right. Well, folks, I got 2 more minutes before I need to go settle my kids down or fighting over video games. Hit me with whatever you got. All right, y'all. Hey, everybody. Thanks for coming. This will be posted all over the internet. And hopefully this is something that's useful we can throw out at people who want to be doing modular monoliths with Wolverine and or Martin. Hopefully I was able to kind of express clearly enough what I think the whole modular monolith thing is probably a little bit overblown, or the hype is premature, but make up your own minds. Everybody, thanks for coming out. Mike, Jeffrey, RB, thanks for the questions. And I'll talk to you guys soon.